I never imagined that, decades later, I would be sitting in front of a camera, telling stories that almost no one knows. I was young, full of courage and fear. When I was assigned to work in one of the most secret factories in the United Kingdom during the Second World War, there, amidst the smell of oil, hot metal, and the deafening sound of the presses, I witnessed the birth of a machine that would change the course of the conflict, the Sherman tank. This account is my memoir of how engineering, human effort, and a touch of genius armored the Sherman and prepared it to face war. I still remember the morning I received the letter as if it were yesterday. It was early 1942, and the war had reached every corner of Europe. The news from the front was relentless reports of battles in North Africa, Eastern Europe, and the Pacific filled the papers. And every soldier, engineer, and worker knew the stakes were higher than ever. I was young, barely out of my teens, working a modest job in a small industrial town. The envelope was unmarked, plain, but the words inside changed the course of my life. I had been selected to join a highly secret British project that very few would ever hear about. The letter directed me to a location miles away from any major city. Directions were cryptic, security protocols strict, and the warning clear. No one outside this assignment was to know my destination or my role. At first, I didn't fully understand what awaited me. I only knew it was important, vital even, to the war effort. They mentioned critical engineering work and armored vehicle production, but the true nature of the project remained shrouded in secrecy. When I arrived, my first impression was of a place unlike any industrial site I had ever seen. High walls, barbed wire, and armed guards patrolled the perimeter. Everything was under strict control. No photographs, no notes, and no personal conversations about the work were allowed. The building itself was massive, stretching far beyond the eye could see. A labyrinth of steel beams, conveyor systems, and the constant, low hum of machinery. This was no ordinary factory. This was the heart of Britain's armoured vehicle program, the hidden engine behind the Sherman tanks that would soon reach the battlefields of Europe. Inside, the atmosphere was tense but purposeful. Men and women moved with precision, each performing their role in a carefully orchestrated operation. I was assigned as a junior assistant, responsible for handling components, observing procedures, and learning the complexities of the work. At first, it was overwhelming. The machinery alone was enough to intimidate anyone. The presses, the lathes, and the furnaces, all working in perfect unison to shape the steel that would protect soldiers on the front lines. Every piece of metal, every bolt, every weld had a purpose. Mistakes could cost lives, and the weight of that responsibility was palpable. I quickly learned that secrecy was paramount. Engineers spoke in hushed tones, blueprints were classified, and the most critical processes were known only to a handful of senior staff. I witnessed the meticulous care that went into designing and assembling each Sherman tank. From the armor plates to the gun turret, from the tracks to the engine, nothing was left to chance. Every component was tested repeatedly before it was deemed fit for assembly. The steel used in the Sherman's armor underwent precise chemical treatments to ensure it could withstand direct hits from enemy fire. These treatments involved heating and cooling cycles, specialized alloys, and quality inspections that could catch even the smallest imperfection. One of the first lessons I learned was the importance of teamwork. Each section of the factory depended on the others. If the armor department delayed, the assembly lines would stall. If welding was imperfect, the final product could fail in combat. The sense of shared purpose was unlike anything I had experienced. We were not just building tanks. We were building survival machines for our soldiers, and every mistake could be fatal. I remember standing by the inspection tables, watching the engineers measure every plate, test every weld, and discuss potential improvements in hushed, urgent voices. It was both inspiring and terrifying. The security measures were intense. I could not talk about what I saw, not even to my family. Guards monitored entrances and exits, and every worker underwent background checks and interviews. The fear of enemy spies was real, and I understood why. The Sherman tank was a crucial part of the Allied strategy. Its success or failure on the battlefield could influence entire campaigns. Knowing that our work might one day decide the outcome of battles added a weight to every task, every decision, every action. During my first week, I was introduced to the various stages of the tank's assembly. The hull, the engine compartment, the turret each had its own team, each with its own set of specialists. I observed how armor plates were cut and shaped, how tracks were assembled, and how engines were tested under extreme conditions. The level of detail was staggering. I realized quickly that producing a Sherman was not merely an industrial task. It was a combination of engineering genius, disciplined labor, and unwavering commitment to secrecy. By the end of my first month, I felt a deep connection to the work. I knew that every action I took, every component I handled, contributed to something much larger than myself. I also knew that I could never speak about it outside the factory walls. The Sherman tanks being built here were destined to fight in Normandy, in North Africa, and across Europe. They were to carry men into battle, protect them from enemy fire, and become symbols of resilience and engineering excellence. Looking back, I understand now that my time in that secret factory was not just about building tanks, it was about building history. Every day was a lesson in precision, secrecy, and responsibility. And though I was young and inexperienced, I became part of something far greater than myself. Something that would change the course of the war and remain hidden in the shadows for decades. The first time I walked through the doors of the secret factory, I felt as though I had stepped into another world. Outside, Britain was at war, rationing was tight, and air raid sirens were a regular part of life. Inside, however, everything moved with a mechanical precision that was almost hypnotic. Endless assembly lines stretched across enormous halls, each one dedicated to a specific stage of the Sherman tank's construction. I realized immediately that this was no ordinary factory, it was a carefully orchestrated system, designed to transform raw steel into some of the most effective armored vehicles the world had ever seen. The sound was overwhelming. Heavy presses shaped steel plates with thunderous blows, lathes spun at dizzying speeds, and the hiss of welding torches filled the air. Sparks flew constantly, falling onto protective mats and scorched metal floors. The smell of burning metal and oil was pungent. But there was a rhythm to the chaos, a rhythm that every worker, from the newest assistant to the senior engineers, seemed to understand instinctively. As I walked down the first corridor, I felt both awe and fear. Every movement mattered, and a single mistake could ruin a tank, or, worse, endanger the soldiers who would eventually depend on it. The factory was divided into specialized sections, each with its own team of experts. One area focused entirely on cutting and shaping the steel armor. The plates were enormous and heavy, often several inches thick, and had to be formed precisely to fit the Sherman's design. I watched engineers use hydraulic presses and custom dies to bend and mold the metal. A process that required not only skill but careful calculation. The type of steel we used was not ordinary, it was a carefully engineered alloy designed to resist penetration by German anti-tank weapons. Each plate was heat-treated, cooled, and inspected multiple times to ensure it could withstand extreme stress. Next, I was introduced to the welding section. Here, the plates were joined together with techniques that combined artistry with science. Welds had to be flawless. Even a minor crack could compromise the tank's ability to absorb an impact. I watched experienced welders work in almost complete silence, their eyes focused, hands steady, as they joined enormous sections of steel into hulls and turrets. The process was exhausting and dangerous. One slip could cause a burn or a structural defect that would only become apparent under battlefield conditions. I quickly realized that welding was as much a matter of survival as it was of engineering. The assembly lines themselves were a marvel of coordination. Components moved along rails and platforms, each station performing a specific task. Engines were installed, transmissions adjusted, and tracks aligned with precision. The Sherman's mobility depended entirely on these exact measurements. Any error could mean the difference between a tank that could traverse difficult terrain and one that would become stuck or break down under combat conditions. I spent hours observing mechanics, check tolerances, test fit parts, and ensure that every system from steering mechanisms to suspension was operational before the next phase. Quality control was intense. Every tank underwent multiple inspections at different stages. Plates were measured for thickness, welds were examined for cracks, and engines were tested for performance. I remember one instance where a hull was rejected because the welding on the turret mount was slightly uneven. The engineers disassembled and remade the section entirely. It was a reminder that, in war, precision was not optional. It was a matter of life and death. Every Sherman that left this factory had to be perfect, or soldiers would pay the price on the battlefield. Even the small details mattered. Seats, hatches, vision ports, and ammunition storage had to be designed not only for functionality, but for the survival of the crew. Engineers debated tirelessly over the placement of armor reinforcements, angles of deflection, and internal layouts to maximize protection. I was struck by how much thought went into each decision. This was not a factory where parts were merely assembled. It was a place where every choice could mean the difference between life and death for men thousands of miles away in North Africa, Italy, or France. Security was everywhere. Guards monitored all entrances, workers carried identification badges at all times, and cameras and checkpoints ensured that no one could take unauthorized photos or notes. Even casual conversation about the work was forbidden outside the factory walls. The secrecy was suffocating but necessary. We were building something that could not fall into enemy hands. If the Germans had learned how we manufactured our Shermans, it could have undermined months of planning and innovation. By the end of my first day, I was exhausted but profoundly aware of the significance of what I had witnessed. This was more than an industrial operation. It was a war effort in microcosm. Every rivet, every weld, and every engine test was a contribution to the Allied strategy. I began to understand that the Sherman tank's success on the battlefield was not just about its design, it was about the people behind it. The laborers and engineers who worked in secrecy, precision, and dedication, day after day, to ensure it would survive the horrors of combat. As I left the factory that evening, I felt a mixture of pride and fear. I was now part of something far larger than myself, a hidden force in the war that few would ever know existed. The path ahead was unclear. But one thing was certain. The Sherman tanks we were building inside those walls would soon carry men into battle, and the quality of our work would be tested under fire. Even now, decades later, I can still hear the hiss of welding torches and the rumble of presses echoing in my mind. That first visit showed me not only the scale of the British war effort, but also the human determination and meticulous craftsmanship that turned raw steel into a machine that could survive, fight, and protect. It was the beginning of a journey that I would carry with me for the rest of my life, a journey into the heart of war, engineering, and secrecy. The most critical lesson I learned during my first weeks at the factory was this: not all steel is created equal. The Sherman tank's effectiveness depended entirely on the quality and treatment of the metal used in its armor. Ordinary steel would not suffice. The plates needed to withstand high-velocity shells, resist shrapnel, and protect the crew from explosions. I quickly realized that this task was as much a matter of chemistry and physics as it was of engineering. The secrets of our steel were closely guarded, known only to a select group of metallurgists and engineers. The process began with the selection of raw materials. Iron, carbon, and other elements were combined in precise ratios to form specialized alloys. The goal was to produce steel that was hard enough to resist penetration, but flexible enough to avoid cracking under stress. Too brittle, and the armor would shatter. Too soft, and it would fail to stop projectiles. Each batch was carefully measured, and I remember seeing engineers weigh elements with incredible precision, down to fractions of a gram. It was meticulous work, and there was no room for error. Once the steel was cast into large slabs, it underwent heat treatment, a process that involved heating the metal to extremely high temperatures and then cooling it under controlled conditions. This hardened the steel and gave it the toughness required for battlefield conditions. Some plates were cooled slowly to increase ductility, while others were quenched rapidly to maximize hardness. Engineers debated the exact temperatures and cooling rates constantly, testing each batch to ensure it met rigorous standards. I was amazed at how much science went into a single plate of steel, something that soldiers would take for granted as just armor. The shaping of the armor was equally critical. Plates were cut to precise dimensions, and edges were beveled to allow proper fitting on the hull and turret. The angle of each plate was carefully calculated to deflect incoming rounds, a technique known as sloped armor. I remember observing a senior engineer explain that a shell striking at an angle would reduce penetration by distributing force over a larger surface area. It was a small detail, but one that could save lives. Welding presented another challenge. The plates had to be joined without compromising their structural integrity. I spent countless hours watching welders practice techniques that allowed the steel to maintain its protective properties. They used layered welding and preheating in some cases, carefully monitoring temperature and penetration. One misstep, even a minor inconsistency in the weld, could create a weak point that an enemy shell might exploit. I realized that our work in this section of the factory directly determined whether a Sherman tank would survive its first encounter with a German panzer. Every plate and weld was subjected to testing before assembly. Engineers struck the steel with hammers, used high-pressure testing machines, and even simulated projectile impacts. Sometimes entire plates were destroyed in tests to ensure that production units would meet the necessary standards. The secrecy around these tests was intense. Only authorized personnel could witness them, and no notes or photographs were permitted. We knew that revealing these methods could give the enemy an advantage, and in a war that already claimed countless lives, that was unthinkable. I also learned about the innovations that made the Sherman uniquely suited to the war. The British factories had worked on improving the armor by introducing additional reinforcement at vulnerable points, such as the front hull and turret ring. Engineers calculated thickness and angles to balance protection and mobility, a compromise that was essential. Too much armor, and the tank would be slow and difficult to transport. Too little, and the crew would be exposed to lethal fire. It was a delicate balance, one that required precision and constant adjustments based on testing and field reports. The steel itself carried a story of human ingenuity. I remember seeing samples under microscopes, examining the crystalline structure of the alloys. Tiny imperfections could affect performance, and the metallurgists would spend hours correcting chemical compositions, adjusting heating cycles, or recommending new treatments. I realized that every Sherman tank was the culmination of countless experiments and refinements, not merely the assembly of parts. Each plate, each weld, each structural choice reflected the intelligence and dedication of those who worked in secrecy. Working in this environment taught me the gravity of responsibility. I was just a small part of a massive operation, yet even my attention to detail mattered. Handling steel plates with care, ensuring correct measurements, and reporting any anomalies could ultimately affect the survival of men thousands of miles away. There was a tangible weight to the work, a constant reminder that our labor was inseparable from the lives of the soldiers who would operate these machines. By the end of my first month in the steel section, I felt as though I had glimpsed the very foundation of the Sherman strength. The tank was not just a machine of war. It was a testament to engineering, chemistry, and human perseverance. Every plate of steel told a story of trial, error, and ingenuity. Every weld was a silent promise to protect the men who would ride inside. And every moment spent in that factory, amidst the heat, the sparks, and the hum of machinery, reminded me that we were not simply building tanks, we were building survival itself. The secret of the steel was more than a process. It was the lifeblood of the Sherman, and understanding it made me proud, terrified, and profoundly aware of the role I played in history. It was a secret that could never leave the walls of the factory. Yet it was the very thing that would make the difference when the first Shermans rolled onto the battlefields of Europe. One of the most intense and unforgettable parts of my work in the Sherman factory was observing and learning the welding process. At first glance, it seemed simple, joining steel plates together. But I quickly realized that welding a Sherman tank was far more than just fusing metal. It was a precise science, a delicate balance between heat, timing, and technique. Each joint, each seam, had to withstand forces that could tear apart ordinary steel. The safety of soldiers thousands of miles away depended on every weld. The hull and turret were the most critical sections. The front armor was designed to take the brunt of enemy fire, so it was the thickest and most reinforced. But simply having thick steel wasn't enough. If the welds were poorly executed, the tank could fail under impact. I watched skilled welders use techniques that combined heat management with multiple layers of fusion. Some areas required preheating of the metal to prevent cracks, while others demanded cooling at precise rates to maintain toughness. It was a meticulous dance between fire and metal. And I often felt the tension in the room, knowing that even a minor error could compromise the entire vehicle. The factory had developed specialized jigs and supports to hold the armor plates in exact positions during welding. The angles of the plates were calculated to maximize deflection of incoming rounds, a principle known as sloped armor. Every plate, every seam, was positioned to redirect energy away from vulnerable sections of the tank. Engineers would spend hours checking angles and alignment before the first torch touched the metal. I learned that the Sherman's survival often depended on these subtle adjustments, invisible to anyone outside the factory but critical in combat. I was particularly fascinated by the turret welds. The turret ring had to be perfectly circular and able to rotate freely while maintaining its protective strength. Engineers reinforced the ring with multiple layers of welded steel, and each joint was examined under magnification. Even tiny inconsistencies were unacceptable. I watched them grind, polish, and re-weld until every joint met their rigorous standards. There was a quiet pride in the workers' shared understanding that these were not just machines, but lifelines for the men who would soon operate them under fire. Welders worked in shifts, their eyes shielded by dark goggles as sparks flew continuously. The sound was constant, a high-pitched hiss of welding, the pounding of clamps holding plates in place, the occasional rumble of heavy machinery. Heat radiated from every station, and the smell of molten metal filled the air. It was exhausting and dangerous work, yet the welders never compromised on quality. I remember seeing one welder remove a partially completed hull because a seam did not meet specifications, even though it meant extra hours and delayed production. The commitment to perfection was absolute. After welding, the plates were often reinforced with additional layers or brackets in strategic locations. This was particularly true for the glacis plate, the sloped front section of the hull and the sides of the turret. Reinforcements were not random. They were based on ballistic tests and combat reports. Engineers knew where the Sherman was most likely to be struck, and they adapted the armor to meet those threats. Watching the combination of engineering calculations, practical experience, and hands-on craftsmanship was awe-inspiring. Quality control extended to every aspect of the welding process. Inspectors used visual examination, ultrasonic testing, and mechanical stress tests to ensure that every seam would hold under extreme conditions. Any defect, even one invisible to the naked eye, could spell disaster in battle. I remember standing at one inspection station, watching a technician check a welded joint with a hammer and gauge. When a minor flaw was found, the piece was immediately marked for rework. There was no compromise. Each Sherman had to be perfect, or the soldiers inside would pay the ultimate price. The welding section of the factory taught me discipline, patience, and respect for craftsmanship. It was physically demanding and mentally exhausting, but it was also profoundly meaningful. Every spark that flew, every seam that held, represented a promise to the men who would ride inside these tanks. I began to understand that our work was not just industrial labor, was a form of protection, a lifeline forged in fire and steel. By the end of my first weeks in the welding area, I could see how every stage of production was interconnected. The steel had to be treated correctly, the plates cut and angled precisely, and the welds executed flawlessly. The Sherman tank was more than the sum of its parts. It was the product of countless hours of careful work, ingenuity, and human dedication. Each tank rolling off the assembly line carried the confidence of engineers, welders, and inspectors alike. A machine designed to survive the most dangerous battlefield conditions imaginable. Even now, decades later, I can recall the heat, the sparks, and the hum of machinery with startling clarity. I can remember the pride and fear that mingled in the eyes of every welder and inspector. Welding a Sherman was more than construction, it was responsibility, precision, and commitment in its purest form. That armor, those welds, and the care that went into them would one day protect men fighting for freedom. And knowing that, even as a young assistant, filled me with a sense of purpose I have never forgotten. The Sherman tank, as I learned quickly, was only as strong as the attention it received before leaving the factory. After weeks working in the steel and welding sections, I was moved to the inspection area, where I gained a first-hand understanding of how meticulous the quality control process truly was. Every Sherman that rolled off the assembly line underwent rigorous checks, because a single flaw could mean disaster for the soldiers who would operate it. I realized that these inspections were not just procedures, they were acts of responsibility, sometimes the difference between life and death. The inspection process began with the armor. Each plate, whether on the hull or the turret, was measured repeatedly. Thickness, angle, and alignment were all verified with precision tools. Even a deviation of a few millimeters could affect the tank's ability to deflect enemy shells. Inspectors used gauges, micrometers, and templates to ensure that every plate met the specifications set by engineers and battlefield analysts. I remember standing at one station, watching a senior inspector examine a turret plate with a magnifying lens, carefully checking for microscopic cracks in the welds. A flaw was discovered, and the piece was immediately sent back for rework. No compromise was allowed. Every Sherman had to be perfect. Mechanical systems were equally scrutinized. Engines were started and run under controlled conditions to detect vibrations, overheating, or leaks. Transmission systems were engaged to test gear shifts, and steering mechanisms were carefully operated to ensure proper response. Suspension systems were loaded with weight simulations to mimic the stresses the tank would endure on rough terrain. Even the tracks were tensioned and tested for durability. I realized that a Sherman could face deserts, muddy fields, or urban rubble, and every inspection aimed to prepare it for those extremes. Ballistics testing was another crucial part of the process. Certain plates were subjected to controlled impacts to simulate enemy fire. Engineers and metallurgists observed how the steel absorbed and deflected the energy of high-velocity projectiles. These tests informed adjustments in armor, thickness, and welding techniques. I remember seeing a small section of a Sherman's hull deliberately struck with a test projectile, and while the metal deformed, it did not fail. Watching that gave me a profound sense of the stakes involved. These tanks had to survive encounters with German, Panzer, and anti-tank weapons. Each successful test meant a higher chance of survival for the crew in real combat. Electrical systems were not neglected. Radios, lights, and control circuits were tested extensively. Every Sherman needed to be operational from the moment it left the factory, and failures in communication, equipment, or controls could be catastrophic on the battlefield. I observed technicians performing these checks methodically, often running multiple tests to ensure redundancy. Each system was vital, because even the most armored tank could be rendered useless by a minor mechanical or electrical failure. The inspection process also included checks for ergonomics and crew safety. Seats, hatches, and ammunition storage were reviewed to ensure functionality and accessibility. Vision ports and periscopes were examined for clarity and alignment. I recall one inspector spending nearly an hour on a single Sherman turret, adjusting the internal layout slightly to make sure that a commander could operate the machine efficiently under stress. Every adjustment, every calibration was a matter of life or death. Time in the inspection area taught me about human diligence. Engineers and inspectors did not rush. The urgency of war was balanced by the need for precision. I remember one day when a nearly completed Sherman failed inspection because a weld on the turret ring was slightly uneven. The entire turret was disassembled and re-welded, delaying production, but no one questioned the decision. The inspector's priority was not speed, it was survival. It was clear that these men and women understood the responsibility resting on their shoulders. I also learned that inspections were not uniform, they evolved based on reports from the battlefield. Feedback from soldiers and commanders was incorporated into new quality checks. Weak points identified in North Africa or Italy led to adjustments in armor thickness, welding techniques, or mechanical tolerances. This continuous improvement ensured that the Sherman tanks produced in our factory were adapted to real combat conditions, increasing their effectiveness and the safety of the men inside. By the end of my first weeks in inspections, I understood why the Sherman was regarded as reliable by Allied forces. Its success on the battlefield was not just a product of design. It was the result of countless hours of scrutiny, testing, and refinement. Every plate, weld, engine, and track had passed rigorous evaluation before leaving the factory. I realized that the Sherman's armor and systems were not simply built, they were carefully verified, stress-tested, and perfected. Standing on the factory floor, watching the inspectors at work, I felt a profound respect for the unseen labor that made these tanks effective. Our work did not take place on the battlefield, but it was as vital as any soldier's action in combat. Every flaw corrected, every system tested, and every plate verified meant that men would survive encounters with enemy fire. The responsibility was immense, but it was a responsibility we bore with pride, knowing that our diligence could save lives in the chaos of war. In the inspection area, I learned the true meaning of precision, accountability, and commitment. The Sherman tank was more than steel and machinery, it was the embodiment of human care and meticulous planning. And for those of us who walked those halls, it was a reminder that, in war, survival often begins long before the first shell is fired. After weeks of working on assembly, steel, and inspections, I was assigned to witness and assist with the secret testing of the Sherman tanks. These tests were unlike anything I had seen before. They were not part of the routine inspections or assembly checks. These were extreme evaluations designed to push the tanks to their limits. The goal was simple but critical: ensure that every Sherman could survive combat conditions, absorb enemy fire, and perform reliably on any terrain. What we did in these testing areas would determine whether soldiers survived or perished when the tanks reached the front lines. The first type of test one observed was ballistic resistance. Certain armor plates or hull sections were deliberately subjected to controlled fire. Engineers used high-velocity projectiles to simulate enemy anti-tank rounds. I watched as metal plates were struck repeatedly, observing the way each layer absorbed impact. Some plates dented, others cracked slightly, but none failed catastrophically. The tests were closely monitored. Metallurgists measured every indentation, every split, every deformation, recording data meticulously. The aim was to understand exactly how the armor behaved under extreme stress, so improvements could be applied before production Shermans were completed. Impact tests were not limited to small sections. In some cases, partially assembled tanks were positioned in reinforced areas where projectiles could strike them at angles simulating battlefield attacks. Engineers studied how shells deflected from sloped surfaces, testing the theory of angled armor in real conditions. Watching a tank endure repeated impacts was both awe-inspiring and terrifying. I could see the intelligence behind the design. The sloped plates did their job, deflecting energy and preventing penetration. It became clear that the Sherman's armor was not just about thickness. It was about strategy, science, and precision. Mobility tests were equally demanding. A Sherman was not useful if it could not move reliably over rough terrain. We tested vehicles over dirt tracks, mud, gravel, and even obstacle courses designed to simulate trenches, bomb craters, and urban rubble. Each tank carried its full load, including fuel, ammunition, and crew simulations. Engineers measured suspension performance, engine output, and track durability. It amazed me how much thought had gone into balancing armor protection with mobility. A heavy tank could survive hits, but if it became stuck or broke down, the crew would be lost anyway. These mobility tests ensured that the Shermans could reach their objectives while withstanding enemy fire. Explosive resistance was another aspect of the secret tests. Controlled detonations were conducted near or under partially assembled tanks to simulate mines or artillery blasts. Reinforcements were checked, welds observed, and the hull's ability to distribute force assessed. I remember the tension in the testing area. Engineers and technicians would retreat to safety behind reinforced barriers, and yet the anticipation of observing the tank's reaction was palpable. Each test provided crucial information about weak points and necessary modifications, which were then immediately applied to production models. Crew simulation tests were conducted simultaneously. Sandbags and weighted mannequins were placed inside to represent soldiers and ammunition loads. Engineers evaluated how the tank would absorb shocks, how hatches and internal components held up, and how accessible controls remained during extreme maneuvers. It was a reminder that the Sherman was not just a machine, it was a mobile fortress designed to protect human lives. The focus on crew survivability was constant, and every adjustment reflected lessons learned from previous combat reports. Secrecy around these tests was absolute. Only authorized personnel were allowed to observe. Notes, photographs, and sketches were strictly forbidden. Guards patrolled the area, and discussions about procedures outside the test zone were prohibited. We all understood the stakes. The techniques and data generated in these tests were invaluable to the war effort. If the enemy had learned how we prepared and reinforced the Shermans, it could have compromised the entire strategy. The tension was heavy, but so was the sense of responsibility. Witnessing the tests firsthand, I gained a deeper appreciation for the Sherman's reliability. Every impact, every obstacle, every simulated explosion was meticulously recorded and analyzed. Adjustments were made to armor angles, weld patterns, suspension settings, and even component placements. It was an ongoing cycle of improvement, ensuring that each Sherman leaving the factory was battle-ready and optimized for survival. By the end of my time in the testing area, I understood that these secret evaluations were as important as any battlefield mission. The Shermans that emerged from our factory were not only products of assembly lines and metallurgical science, they were the results of rigorous trials, relentless scrutiny, and countless hours of human dedication. I left the test grounds with a profound respect for the work being done, knowing that these machines, tested to their limits, would carry men safely into combat and give them a fighting chance against formidable enemies. Even now, I remember the echoes of shells striking plates, the rumbles of engines over simulated terrain, and the controlled detonations that shook the ground beneath us. These memories remind me that behind every Sherman tank in the war, there were countless people like me, working in secrecy, precision, and dedication, ensuring that the steel we forged would protect lives and make a difference in the war. As the months went by, I began to understand the true intensity of working in a wartime factory. The Sherman tank was no ordinary product. It was a lifeline, a symbol of hope for soldiers facing the horrors of the front lines. Every tank we produced was expected to perform under extreme conditions, and the pressure on every worker, engineer, and inspector was immense. There was no room for delay or error. Every hour counted, and every mistake could have consequences far beyond the walls of our factory. The pace of production was relentless. We were constantly aware of reports from the front, where Allied forces relied on the Sherman to advance, hold positions, and provide support in battles from North Africa to Italy and, later, Normandy. Delays in delivery could directly affect operations, and everyone knew it. Managers and engineers monitored assembly lines closely, ensuring that each station functioned efficiently. Workers were pushed to complete tasks quickly, but without sacrificing quality. It was a delicate balance. Speed could not come at the expense of safety or durability. Long hours became the norm. We often worked 12-hour shifts, sometimes longer during critical production periods. Fatigue was constant, but the understanding of the tank's importance drove us forward. I remember feeling exhausted, yet compelled to keep moving, checking welds, monitoring components, and assisting where needed. The noise, heat, and smell of metal and oil became part of daily life, and the hum of machinery seemed to echo the urgency of the war itself. Errors were not tolerated, yet they were inevitable under such pressure. When a weld was imperfect or a plate misaligned, production halted until corrections were made. At first, I was frustrated by these delays, but I quickly realized their necessity. Every Sherman leaving the factory represented soldiers' lives. A flawed tank could mean the difference between survival and death in combat. The stakes were real, immediate, and unforgiving. Coordination between departments was critical. The steel and welding teams, the assembly lines, the inspection units, and the testing teams all had to work in perfect harmony. A delay in one section could disrupt the entire workflow. I saw firsthand how engineers communicated continuously, adjusting schedules, reallocating resources, and troubleshooting issues as they arose. It was a constant exercise in problem-solving, collaboration, and vigilance. The complexity of the operation was staggering, and yet it was executed with remarkable precision. The psychological pressure was intense. Rumors from the front, reports of heavy casualties, and the urgency of impending battles created an atmosphere of tension. Every worker knew that the tanks we built could determine the outcome of engagements, protect soldiers from enemy fire, and support broader Allied strategy. That knowledge weighed heavily on everyone. We understood that failure was not an option, and the responsibility was both motivating and overwhelming. I remember one night when a batch of tanks was nearly ready for shipment, but the inspection team discovered a critical flaw in a turret ring weld. Production had to stop immediately while corrections were made. Engineers and welders worked through the night, guided by a shared sense of urgency and responsibility. By morning, the problem was resolved, and the tanks were once again on schedule. That incident taught me that precision and speed were not mutually exclusive. They had to coexist for the Sherman to fulfill its role in the war. The factory leadership emphasized morale and resilience. We were encouraged to focus on the importance of our work, knowing that each tank was more than machinery, it was protection, firepower, and hope for soldiers facing combat every day. Posters, briefings, and occasional visits from military officials reminded us that the tanks we produced had a direct impact on the war. This sense of purpose helped sustain us during the most exhausting shifts. Despite the relentless pace, I also saw moments of pride and accomplishment. Watching a newly completed Sherman roll off the assembly line, knowing it had passed every inspection, endured testing, and was ready for deployment, filled the entire workforce with a sense of achievement. We were not just producing vehicles. We were contributing directly to the war effort. Each tank was a testament to human effort, ingenuity, and dedication. By the time I had been in the factory several months, I had come to understand that the pressure was part of what made the Sherman successful. The intensity of production, the careful coordination, and the constant vigilance ensured that each tank met the highest standards. The men and women in the factory were aware of the stakes, and that awareness drove us to perform at our best, despite exhaustion and stress. The pressure of war shaped every decision, every motion, and every process in the factory. It was a constant reminder that the Sherman was not merely a machine. It was a lifeline for those who depended on it. And though the work was grueling, the knowledge that our efforts directly contributed to the survival of soldiers gave every task meaning. Every Sherman that left the factory carried with it our sweat, skill, and unwavering commitment to the war effort. Even now, I remember the relentless rhythm of the factory, the clang of metal, the roar of engines, the voices of engineers, and the constant movement of workers. That pressure, though exhausting, was what forged the Sherman into a reliable and resilient tank, ready to face the battlefield and protect the men who rode within. It was the pressure of war that transformed steel, sweat, and determination into one of the most iconic armored vehicles of the Second World War. One of the most striking aspects of working in the Sherman factory was the absolute level of secrecy that enveloped every corner of the operation. From the moment I first arrived, it was made clear that the work we did could not be discussed with anyone outside the factory. Not family, not friends, not even colleagues in unrelated departments. The factory was a world unto itself, and the secrets it contained were considered vital to the success of the war. Security started at the perimeter. Guards patrolled continuously, checking identification cards and questioning anyone approaching the gates. Barbed wire fences and reinforced walls ensured that the facility was off-limits to the general public. Even deliveries of raw materials were carefully monitored. Trucks were inspected, and manifests were verified to prevent sabotage or theft. We were reminded repeatedly that enemy agents were a real threat, and that any breach of security could have catastrophic consequences. Inside the factory, secrecy was enforced with equal rigor. Blueprints were classified, stored in locked cabinets, and accessible only to senior engineers. Notes could not be taken outside of designated areas, and discussions about the work were limited to immediate teams. Even casual conversations about processes were prohibited. I quickly learned to speak in generalities and to avoid specifics when asked about my work outside the factory. The rules were strict, and everyone understood that violations could result in dismissal. The rationale for such stringent security was clear. The Sherman tank was one of the most important contributions to the Allied war effort. If the enemy had discovered how it was constructed, how its armor was treated, or how its mechanical systems functioned, they could have developed countermeasures or sabotaged production. Every tank leaving the factory represented lives, and any compromise in security could put soldiers at risk. We were not just manufacturing vehicles. We were safeguarding the strategic advantage of the Allies. Security extended to internal operations as well. Certain areas of the factory were restricted to specialized personnel. For example, the metallurgists responsible for treating the armor steel were isolated from the assembly line. Only authorized engineers could access critical welding procedures or assembly jigs. Even within the factory, information was compartmentalized. Workers often knew only enough to perform their own tasks efficiently, without understanding the full picture. This system minimized the risk that any single worker could unintentionally expose crucial secrets. I remember one incident where a visitor attempted to gain access to a sensitive area. The security personnel responded immediately, escorting the individual out and reviewing procedures to prevent future attempts. Everyone in the factory was aware of the risks posed by espionage. It was not paranoia. It was a necessary vigilance. The consequences of a breach could have extended far beyond the factory, directly affecting soldiers in the field and operations across multiple theaters of war. Even casual gestures were monitored. Cameras, guards, and strict protocols ensured that no one could photograph equipment or record processes. Conversations were conducted in low tones, and workers learned to maintain discipline at all times. The culture of secrecy became ingrained in daily life. I found myself constantly aware of my surroundings, careful with words and actions, and fully committed to preserving the integrity of the operation. The secrecy also affected our personal lives. I could not tell my family where I worked or what I did. Friends outside the factory had no idea of the scale, complexity, or importance of the Sherman tanks being produced. This isolation was challenging at times, but it reinforced the gravity of our responsibilities. We understood that the Sherman was not just another piece of machinery, it was a lifeline for soldiers fighting on multiple fronts. And protecting the knowledge of how it was built was as crucial as building it itself. I also observed how secrecy influenced innovation. Engineers had to solve complex problems within a closed environment, sharing solutions only with trusted colleagues. There was no room for public discussion or collaboration with outside experts. This created an intense focus on precision, problem-solving, and accountability. Every modification, every improvement, had to be carefully documented internally and implemented discreetly. The result was a tank that not only performed reliably, but had been refined under conditions of extreme caution and diligence. By the time I had been in the factory several months, the culture of secrecy had become second nature. I understood that every plate welded, every engine tested, and every inspection completed was protected by layers of security protocols. The Sherman tanks we produced were not only engineered to withstand enemy fire, they were guarded by the knowledge that few would ever see. A hidden shield protecting soldiers even before the tanks reached the battlefield. Looking back, the lessons of secrecy were as enduring as those of steel and welding. The factory taught me that security was not just about preventing theft or espionage, it was about responsibility, vigilance, and the understanding that our work had consequences far beyond our immediate surroundings. In many ways, the silent discipline of secrecy was as crucial to the Sherman's success as the armor itself. It was a reminder that in war, knowledge is power, and protecting that knowledge can save lives just as surely as a well-welded plate or a perfectly aligned track. Even now, decades later, I can recall the hushed corridors, locked doors, and vigilant guards. I remember the feeling of responsibility that came with knowing that everything we did in that factory was hidden from the world, but that secrecy was the shield that would help our tanks and our soldiers survive the war. The final stage of our work with the Sherman tanks was the most intense and humbling, preparing them for transport and deployment to the front lines. After weeks of assembly, welding, testing, and inspections, each tank was carefully prepared for a journey that would take it thousands of miles to face the realities of war. Watching this process, I realized that our responsibility did not end with building the tanks. It extended to ensuring that each one arrived in perfect condition, ready to protect the men who would ride inside. Once a Sherman passed all inspections, it was moved to the shipping area. The sheer size and weight of these machines made this process a logistical challenge. The hulls alone weighed over 30 tons, and with fuel, ammunition, and other equipment loaded, they were even heavier. Massive cranes, rails, and specialized transport vehicles were used to maneuver them safely from the assembly line to the docks. Every movement had to be calculated to avoid damage, because even minor dents or misalignments could compromise performance once the tank reached combat. Before loading, Engineers conducted final checks. Engines were started, transmissions tested, and tracks inspected one last time. Fuel tanks were filled, lubricants applied, and batteries connected. I watched mechanics go over every system meticulously, knowing that once a tank left the factory, there would be little opportunity for repairs until it reached its destination. The pressure to get everything right was immense, but no one rushed. The men in the factory knew that the Sherman's first moments in the field depended entirely on our diligence. The shipping process itself was an operation of precision. Tanks were loaded onto specially reinforced railcars or transport ships. Straps, chocks, and braces were used to secure them, preventing movement during travel. Engineers monitored the balance of weight carefully. Improper loading could cause mechanical stress, damage, or even accidents during transit. I remember standing on the docks as workers guided a Sherman onto a ship, the tank's massive treads grinding against the metal ramps. The coordination required was incredible, and every worker knew that a single mistake could ruin days of labor or worse. Once on board, tanks were secured for sea transport. Wooden chocks were positioned beneath tracks, heavy chains anchored the hulls, and the decks were inspected repeatedly. Sea voyages were perilous. Storms, rough waters, and enemy threats posed constant risks. I recall the anxiety among the factory workers and engineers, knowing that the tanks could be damaged before they even reached the front. Extra precautions were taken, from waterproof coverings to reinforcement of vulnerable points, ensuring that each Sherman arrived operational. Documentation was another critical component. Every tank was logged with serial numbers, inspection reports, and shipment details. The military needed to know exactly which tank was in which convoy, and every minor adjustment or repair was recorded. The accuracy of this paperwork was essential for logistics and coordination on the front lines. Misplacement or misidentification could lead to confusion, delays, or worse, mechanical failures that might cost lives in combat. During this stage, I also learned about the coordination between factories, ports, and military units. Engineers, logisticians, and military officers communicated constantly, ensuring that tanks arrived at the correct destination, equipped with necessary supplies, and ready for immediate deployment. Convoys were carefully planned to reduce the risk of enemy interception or accidents. Every step was synchronized with broader military operations. It was a complex system, and observing it gave me an understanding of the scale and importance of the Sherman program in the larger context of the war. Preparation for frontline service included minor adjustments based on anticipated conditions. Tanks bound for the deserts of North Africa received modifications to their cooling systems to prevent overheating, while those destined for Europe were outfitted with additional protection against cold, mud, and rough terrain. Engineers and mechanics applied these enhancements with the same meticulous attention that had characterized every stage of production. The goal was to ensure that no tank would fail due to preventable environmental challenges. As I watched the final tanks leave the factory, I felt a mixture of pride, anxiety, and responsibility. These machines represented months of labor, skill, and human dedication. I knew that the men who would ride them into combat would rely entirely on our work. It was a profound realization the Sherman was more than steel and machinery. It was a protective shield, a tool of survival, and a symbol of our contribution to the war. Even after decades, I can recall the sight of those massive tanks being loaded, secured, and sent off. The sound of engines starting, chains tightening, and cranes moving was accompanied by a heavy sense of purpose. Each Sherman that left the factory carried not only fuel and ammunition, but also the labor, knowledge, and hope of the people who built it. The journey from factory to front line was the final test of our commitment, and ensuring that every tank arrived ready for battle was as crucial as building it in the first place. After months of assembly, welding, inspections, testing, and careful preparation for transport, the Sherman tanks finally arrived at the Vietnams. Watching them disembark from ships and rail cars was an unforgettable moment. These machines, the culmination of our labor and dedication, were now about to face the realities of combat. I remember the tension among soldiers and officers alike. They were eager to test these tanks in battle, but they knew that even the most meticulously prepared machine could not guarantee survival in the chaos of war. The Shermans were deployed to multiple theaters: North Africa, Italy, and later Normandy, and their arrival brought a noticeable shift in operations. Soldiers who had previously relied on lighter, less armored vehicles were now given tanks that could engage enemy panzers with increased confidence. I received reports from contacts who described the impact on morale. The sight of a fully armed Sherman rolling into position inspired hope and provided a psychological boost to infantrymen who understood that these tanks were designed to withstand hits that would destroy other vehicles. Combat performance varied depending on terrain and enemy forces, but one constant was the durability of the Sherman's armor. In North Africa, the tanks endured long marches through deserts, with engines and cooling systems tested to the limit by extreme heat. Soldiers reported that the sloped armor deflected many of the anti-tank rounds they encountered, protecting both the crew and vital components. Each account I received confirmed that our work in the factory, careful welding, armor treatment, and final inspections directly translated into lives saved on the battlefield. In Europe, the Shermans faced different challenges. The hedgerows of Normandy, urban rubble, and icy conditions required the tanks to perform with agility and reliability. I read reports describing how the suspension and tracks, tested repeatedly in the factory, allowed Shermans to navigate obstacles that would have immobilized lesser tanks. The ability to maneuver effectively gave infantry units strategic support, allowing them to advance while under fire. It was clear that the engineering decisions made months earlier, during testing and preparation, were proving crucial in real combat conditions. The first encounters with German panzers highlighted both the strengths and weaknesses of the Sherman. While the armor often protected crews against lighter anti-tank weapons, heavier German guns could penetrate it. I learned that adaptations were implemented in the field: additional armor plates, sandbags, and modifications to turret layouts to improve survivability. Reports from the front indicated that these field modifications were sometimes inspired by our own factory testing, showing the direct connection between controlled tests and battlefield innovation. Crew experience played a significant role in the tank's effectiveness. Soldiers trained to operate the Sherman quickly learned to exploit its mobility, firepower, and armor. They developed strategies that maximized protection while engaging enemy forces. I remember reading letters from soldiers describing the trust they placed in their machines, trust that stemmed from the reliability, precision, and quality we had ensured in the factory. The knowledge that their tank would perform as expected under fire allowed crews to focus on tactical maneuvers rather than worrying about mechanical failures. One of the most remarkable aspects of the Sherman's deployment was its adaptability. Variants were developed to meet specific combat needs, such as mine-clearing versions, flame-throwing modifications, and bridge-laying tanks. These adaptations often began in factories like ours, where engineers collaborated closely with military planners to create solutions for challenges reported from the front. Seeing the Sherman evolve in response to real-world conditions reinforced my pride in our work. We were not just producing a standard tank. We were contributing to a machine that could adapt, survive, and support troops in a variety of environments. The impact on the war effort was substantial. Allied forces credited the Sherman with helping to break stalemates, support infantry advances, and provide mobile firepower in engagements where lighter vehicles had failed. While losses were inevitable, the Sherman's combination of armor, mobility, and firepower often gave crews the upper hand. It was clear that the meticulous processes we followed, careful alloy selection, welding, testing, and inspections, had directly influenced the outcome of engagements. Lives were saved, objectives achieved, and progress maintained because of the dedication we had invested months earlier in a factory far from the battlefield. Even as the Sherman faced the harshest conditions, the soldiers' reports reassured me that every detail mattered. A properly aligned turret, a welded seam that held under impact, or a suspension system tested under simulated loads made tangible differences in combat performance. I realized that our work had been more than industrial labor. It had been a vital contribution to survival and mission success. The machines we built were not perfect, but they were reliable, adaptable, and life-saving, and that reliability stemmed from the precision and care we had applied at every stage of production. Standing in the factory months earlier, I could not have imagined the full scale of the Sherman's impact. Now, seeing reports from the front, understanding the challenges faced by crews, and learning how the tanks performed under fire, I felt a profound sense of accomplishment and responsibility. The Sherman was more than a tank. It was a lifeline, forged in secrecy, tested rigorously, and delivered with purpose. Its story was a testament to human ingenuity, discipline, and the unwavering commitment of countless men and women who worked behind the scenes to give soldiers the best chance at survival. The Sherman's journey from raw steel and welding sparks to the thunder of combat was a story of precision, courage, and resilience. And for those of us who had been part of its creation, the knowledge that our work had made a difference in the lives of men facing the dangers of war was a lasting and humbling legacy. Every tank that reached the front was a reminder that meticulous effort, teamwork, and dedication could change the course of battle and, ultimately, the course of history.